All right, here is some help if you need help on number 1. It says the function h of t equals negative 16t squared plus 16t plus 50 models Miguel's cliff jumping experience. In this function, h of t represents Miguel's height in meters during the dive as a function of t seconds. Use the function to answer the questions below. And we're going to round to the nearest tenth. So right now it says, what is the height of the cliff relative to the water? So I'm going to write down the problem right over here. It always helps for you to draw a picture if you're not sure what's going on. So here is, let's see, a person. That is jumping off cliff, goes down to the water. And we can see that this is the x-axis and this is the y. This is where the person is jumping off of the cliff on the y-axis. So this is our y-intercept. So for part A, when it's asking what is the height of the cliff relative to the water, I'm looking for the y-intercept. So that should be 50. So I'm going to write here, part A, it should be 50. And then it says that we are talking about meters. So let's put down 50 right here. And this will be meters. Okay, next part, how high is Miguel at his highest point relative to the water of the jump? So the highest point, if I look at my picture, that would be right up top. This is my vertex. So if I'm looking for my vertex, I know that I need to use negative b over 2a. Okay, so right over here, let's use negative b over 2a. So that's going to give me negative 16 over 2 times a, which is negative 16. So this is going to give me negative 16 over negative 32, which just simplifies to, let's make it a decimal, 0.5. Okay, this would give me the time it takes me to get to how high the jump is. So I need to actually take this and plug it back into my equation. So this is going to give me negative 16 times 0.5 squared plus 16 times 0.5 plus 50. Okay. And when I simplify all this, I should get 54. And this right here, this should be my answer. And since I'm talking about how high the point is, that means that my answer is going to be in meters as well. So let's put down 54 and then meters. Or meters. Okay, next question. How many seconds until he is the same height as the cliff during his descent? So same height as the cliff during his descent. I'm gonna teach you guys a shortcut real quick. So this is my axis of symmetry, right? I know that from here to here, I solved for this earlier, it would take me 0.5 seconds. So if it takes me 0.5 seconds to get from here to the middle, it should take me another 0.5 seconds to reach the same height again. So when I add that up together, that should give me 0.5 plus 0.5, 1 second. So I'm going to say this would give me 1 second to get to the same height. Okay, lastly, what time does Miguel enter the water? Remember I said that if you're looking for when you enter the water or when you hit the ground, then that is like solving for the x-intercepts. We need to solve for the x-intercept. And so let's go ahead and use the quadratic formula when you're looking for the x-intercept. So I'm going to do negative b, waiting for it to focus a little bit. Okay, negative b. Actually, let me go ahead and plug it in right away. negative b plus or minus the square root of b squared minus 4a and then c all over 2a. My a is negative 16. Good. And I'm not gonna show you guys how to calculate this into your calculator. If you need help with this, let me know, or let your teacher or tutor know. But after this, you just simplify inside, plug it into your calculator. You should round it and get the answer of 2.3. Okay, so let's put in 2.3. 2.3, and then we're talking about time, so it should be seconds. Okay, so let's go ahead and check. Here's my next button. Okay, I only did number 1 for this one, so let's see. There you go, everything right for number 1.